Okay, this last topic is on constant and changing velocity problems. It's the kind of the end of the acceleration topic for now. We'll probably talk about it for the entire year. Semester, I should say. But first thing I want you to do is you should be able to do this question. And if you can't, you should go back and watch video number 11, which is Excel formulas. So pause the video and try this, starting by making a list. Here's the answer, so pause if you're not ready. Baseball is dropped, so I know acceleration of falling objects is 9.8 meters per second squared. Time equals 3 seconds. Velocity initial equals 0. Distance initial equals 0. Distance final is what I want, or change in distance. Treat them the same. Distance initial plus velocity initial times time plus 1/2 AT squared. 0 plus 0 times 3 is 0 plus 1/2 9.8 times 3 squared equals 4.9 times 9, which equals, do I have a calculator? Yes. By the way, 1/2 times 9.8 is 4.9. 4.9, that's where that came from, times 3 squared is 9. 3 squared is 9. The answer is 44.1 meters. Okay, new topic. Skip this for now. This is accelerating and constant motion, and as a review, you need to know by now. Acceleration, an object is moving with constant motion when, or constant velocity, when there's no change in velocity. It's going the same speed. An object is accelerating when we could have increasing velocity, we could have decreasing velocity, or in general, velocity is changing. So this could technically also mean it's just changing direction. So let's look at example number 1. Oh, by the way, one more thing. Here's the formulas we need for all of these. I'll do these because formulas are in green. Distance equals velocity times time, and that's constant velocity. Distance final equals distance initial plus VIT plus 1/2 AT squared. V final squared equals V initial squared plus 2A change in distance. Velocity final equals velocity initial plus acceleration times time. You'll need those today. Have those written down. So, follow along. Do not copy these words. Just copy this process, because what we're going to do is we're going to take stuff that we already know, and we're going to turn it into a example problem. So let's call this example 1. Write that down, constant and changing acceleration. Because what happens is we're driving for 1 minute at a speed of 20 meters per second. So part 1 is constant velocity. Time must be in seconds. Velocity equals 20 meters per second. And in the end, we want to know the total distance, because the car in front of you stops and you decelerate at this rate for 4 seconds. We want to know the total distance when you're moving, cool, and then when you start slowing down. So this part finishes up as distance equals velocity times time, 20 times 60, 1,200 meters. That's part 1. Part 2, I'll do it in red, is changing velocity or acceleration. Changing velocity, same thing. So we know that Right before it started accelerating, slowing down, it was going 20 meters per second. We don't know v final. It doesn't say for sure that it came to a stop. But I know time equals 4 seconds. Acceleration is -3 meters per second squared. It's decelerating. And we need to find distance final here. So we can use distance final equals distance initial plus velocity initial times time plus 1/2 at squared. Distance, this is our question, distance initial 0 equals velocity initial times 3 plus 1/2 -3 times 4 squared equals 60 plus 1/2 of 3. Well, let's do 4 squared. 16 cut in half. -3 times 8 equals 60 minus 24 equals 36 meters. 36 meters plus 1,200 meters, our total distance for when we're moving at constant velocity and when we are accelerating is 1,236 meters. That's example number 1. Example number 2 is when we need multiple acceleration formulas. So let's start with a list. This will make more sense in a little bit. Car starts at rest. Velocity initial equals 0. Reaches a velocity of 25 meters per second in just 5 seconds. How far did it travel? I know distance initial 0. So there's 2 formulas that we could use. Distance final equals distance initial plus v initial times time plus 1/2 at squared. I like that one because my velocity initial is 0. So plug it in. Equals 0 plus 0 times 5 plus 1/2, I don't know, acceleration times 5 squared. So I need to know this before I can get to this. So this is a 2-step problem. But I do know velocity final minus velocity initial plus acceleration times time. I have this stuff to solve for acceleration, and now I'll just plug it in there. 25 equals 0 plus acceleration times time. 25 equals acceleration times 5. This is a times 5, so I divide by 5. Acceleration equals 5 meters per second squared. So I'll plug that in there. Now distance final equals 0, 0, 1/2, 5 times 5 squared equals 25 times 5, 125 times 1/2 equals 125 divided by 2. I don't know what that is. 125 divided by 2, 62.5 meters. So to summarize, we made a list and picked out a formula, but we found out we were missing one more thing. So we had to solve for that thing first and then plug it into the other formula. At the end, in order to practice these are complicated. They're not really new, but they are complicated. So on page 69 in your textbook, you have these 2 right here. And then 30 through 38 is on page 71. I want you to do those. Here's all the answers. Practice this, because on your test you will get 2 questions and it'll be out of 1 point. So if you get them both right, that's 1 point extra credit on your test, equals about a 7% boost in your grade. So take the time to do this, because this is an extra incentive. These are time consuming, they involve some thought, you need to work out the math. Take the time to practice these, because this is big time extra credit on the actual test. Also, I will do a video explaining 27 and 30, and maybe one more, maybe 31. There'll be another video, but that won't be out until later on the 1st.